Hi everyone, in this video we're going to learn how to write balanced chemical equations. Before we start, you can download this handout by following the link in the description below, so you can follow along the video. So let's get started. So by now you should be able to write word equations, and in a word equation we see that on the left hand side we put the reactants, and on the right hand side we have the products. But then why do we have to go one more step to write a chemical equations? So pause the video, think about what are the limitations of a word equation, and we'll discuss that in a minute. So usually chemical reactions are represented by means of a chemical equation rather than a word equation. A word equation does not show the chemical formulas of the different substances, and they also do not tell us the proportions in which these substances react in a chemical equation. So we're going to move on and look at how to write a balanced chemical equation. Basically, we change all the words into chemical formula, and the chemical equation must contain an equal number of atoms on both sides of the equation. So let's begin with one example. In this video, you will see 15 different examples, and we will cover about 5 to 6 different tips for you to balance the chemical equation. There is no one method in balancing a chemical equation, but with practice and if you know some of these tricks, you would be able to do so quickly and effectively. Let's look at example 1. This is a very simple example, the reaction between hydrogen and oxygen to form water. So let's take a look at these equations modeled with some actual molecular models. So hydrogen oxygen forms water. So hydrogen, as we know, is a diatomic molecule, H2. So this is represented by the white colored balls, H2, and oxygen we know is O2. Okay. And water, H2O, this is what it looks like. So let's write that down in terms of the chemical formula. H2 plus O2 gives H2O. In order for an equation to be balanced, there must be an equal number of atoms on both sides. So we can see here, we have 2 hydrogen atoms on the left and 2 hydrogen atoms on the right. So actually hydrogen is balanced. We now look at oxygen. We have O2, right? So we have 2 oxygen atoms on the left, but we only have 1 on the right. So oxygen is not balanced. What can we do? Well, we can't just put 1 oxygen atom there. That wouldn't make sense. We have to add in molecules of water. Okay, we cannot just add 1 oxygen there. Okay, it doesn't fit the reaction at all. So we can only balance the 2 oxygen on the left by adding 1 more water molecule on the right. Now we say that oxygen is balanced because there is 2 on the right, 1, 2, and we have 2 oxygen on the left. But now we have another problem. There is 4 hydrogen on the right, but we only have 2 on the left. So now we can balance hydrogen by adding 1 more molecule of hydrogen like that. So a balanced chemical equation basically puts down numbers of molecules that react. So it shows us the ratio in which these molecules react in a chemical reaction. So 2 hydrogen molecules and 1 oxygen molecules form water. So the first step of every chemical equation is to write the chemical formula down. So hydrogen is H2, remember it's diatomic. Oxygen is O2. And water is H2O. This is a chemical equation, but it is not balanced because the number of oxygen atoms on the left and right side are not the same. On the left we have 2, on the right we have only 1. How then can we balance a chemical equation? We can only balance equations by adding numbers in front of the substance itself, so we cannot add numbers behind. So on the left hand side, if I have 2 oxygen, on the right hand side I must make that 2 as well. So the only thing I can do is to put a 2 in front here. So this means there will be 2 times 2, 4 hydrogen, and 2 times 1, 2 oxygen. So right now I have a total of 4 hydrogen and 2 oxygen on the right side. Oxygen is balanced. Now look at hydrogen. I have 2 on the left and 4 on the right. So in order to make this 4, I times 2 here. Okay, so let's erase all this. We can now see why this is balanced. On the left hand side, I have 4 hydrogen. Right hand side, I have 4 hydrogen. On the left hand side, I have 2 oxygen. And on the right hand side, I have 2 oxygen. So this is the balanced chemical equation. So once again, to reiterate, we can only add numbers in front of the substances. Okay, and we have a name for all these numbers. These are called your coefficients. So this tells us that 2 hydrogen molecules react with 1 oxygen molecule to form 2 molecules of water. So one advantage of a chemical equation is we can see the proportion in which these substances react. We can't see that in a word equation. Okay, so basically we are done with example 1. Let's move on. I would now like to reiterate some rules for balancing equations. Number 1, using the same example that we have, we cannot change the numbers that are below here. These are called the subscripts. Okay, so like water is H2O, right? We can't add a 2 behind that to change that to H2O2. This is not allowed. Okay, so you cannot change the subscripts. The second rule is that you cannot place a coefficient in the middle of the formula. So let's say if we need 2 oxygen, we cannot put a 2 in between here. So whatever that you do, don't put numbers anywhere else except in front of the substances that are in the reaction. Okay, a third rule is that you must always reduce the numbers to the lowest terms. So look at the example here. This is a balanced equation. Okay, there are the equal numbers of atoms on both sides. But then they can be further simplified. So 4 to 4 can be simplified to 2 is to 1 is to 2. So always reduce the ratio to the simplest ratio. Alright, and the last rule is again, even if we want the simplest ratio, we can't have fractions in our final answer. Okay, so half 1 1 is not allowed, so we will have to change that. Okay, at this point, I would need you to be sure of the difference between these 3 different expressions, H2, 2H, and 2H2. So H2 refers to 2 hydrogen atoms that are chemically combined. So this is a hydrogen molecule. 2H simply refers to 2 different hydrogen atoms and they are not combined, so separate. 2H2 will be 2 hydrogen molecules. And this is how we can represent them. Okay, so hopefully you are clear as to what the numbers behind and in front actually mean. Let's look at example 2. You can pause the video and then check your answer later. So the first step is to write the chemical formula. So we have nitrogen reacts with hydrogen to form ammonia. So nitrogen and 2 hydrogen to form ammonia. Even though they never mention to balance the equation, it is always understood that whenever they ask for an equation, by default it must be a balanced chemical equation. Okay, they may not always say that in the question. They usually just say write an equation. Okay, we start by looking at nitrogen. On the left hand side we have 2 nitrogen, on the right hand side we have 1. how to make that the same? We put the 2 in front here. Okay, so now nitrogen is balanced. Let's look at hydrogen now. 2 times 3, so I have 6 hydrogen on the right side. Okay, I have 2 on the left. So how do I make that the same? I put a 3. So 3 times 2 is 6. So this is the final answer. N2 plus 3H2 gives 2NH3. Moving on to example 4. Moving on to example 3, write an equation to represent the reaction between magnesium and hydrochloric acid. So magnesium is Mg. Okay. Many students tend to write Mg as Mg2 plus Mg2. These are wrong because we are referring to the element itself, not the ion. Okay, and you know that magnesium is a metal. It doesn't form molecules like that, Mg2. That is also wrong. So for all metals, just write the symbol. Hydrochloric acid is HCl. Metal plus acid gives salt plus hydrogen. So you have to know all your reactions very well. Let's look at magnesium. Magnesium is balanced, 1 here, 1 here. We now look at hydrogen. There is 1 hydrogen here, 2 hydrogen here, so we have to put a 2 in front. Okay. We now check chlorine, 2 on the left, 2 on the right. So the equation is balanced like that. Okay, example 4. Step 1, write all the chemical formula first. Calcium carbonate. Okay, again we check the atoms on the left and right. On the left I have 1 calcium on the right. It's balanced. Okay, 1 carbon here, 1 carbon here, also balanced. 3 oxygen here. I have 2 here and I have 1 here. So on the right hand side I also have 3 oxygen. Let's look at hydrogen. On the left I have 1, on the right I have 2. So I need to put a 2 in front so that they have the same number of hydrogen atoms on the left and right. And now chlorine is also balanced. Okay, 2 here and 2 here. So there you have it. This is also the balanced chemical equation. Okay, let's move on to some other examples. And in these examples that follow, I'll also be sharing different tips that apply to different kind of chemical equation. So over here we have the combustion of methane. You see that oxygen appears many times in the equation. So usually when we balance equation, we start with the element that only appears once on the left and on the right. So carbon would be a good one to start with because there is 1 here and 1 here. Okay, if you want to start with oxygen, okay, you have to look at 2 different things which can be a little bit confusing. Also, you will notice that this plus oxygen gives carbon dioxide plus water. This is a type of reaction known as combustion. Okay, you would recall learning this before in the chapter on chemical changes. So for combustion of hydrocarbons, these are called hydrocarbons. That means they contain carbon and hydrogen. Okay, we always balance in this following sequence. Balance carbon first, then balance hydrogen, then balance oxygen. Okay, this rule or tip applies to all kinds of combustion of hydrocarbons. So let's apply this to this equation. Look at carbon first. So on the left we have 1, on the right we have 1. Done. So we go next to hydrogen. 4 on the left, okay, 2 on the right. How do I make this 4? I just times 2 in front. Okay, now we count oxygen. Okay, there is quite a lot to look at for oxygen. There are 2 here. Okay, there's 2 here. There's 2 here. Okay, on the right I have total of 4. So to balance oxygen, I will put a 2 in front here. Okay, so this is the balanced chemical equation. Now you try to apply the same rule or tip to balancing the combustion of propane. Okay, again, going in the order, balancing carbon first, then hydrogen, then oxygen. Okay, so pause the video and try that now. Alright, so again, to balance carbon, there is 3 on the left, so this side must be 3. Then we balance hydrogen, there is 8 here, so 4 times 2 is 8. Then we look at oxygen, 3 times 2 here, I have 6 oxygen. 4 here, so total oxygen on the right I have 10. On the left I have 2. 2 and 10. How to balance? We'll put a 5 here. Okay, so the correct answer should be 1, 5, 3, 4. Whenever the coefficient is 1, we usually do not write it down. Okay? Okay, let's move on to another tip in balancing equations. So this is the reaction between sodium and oxygen. And the tip is to use fractions, as fractions are a useful way to balance equations. Okay, so over here, if we want to look at sodium, alright, so let's look at balancing sodium first. So on the left I have 1, on the right I have 2, right? So I'll put a 2 in front. On to oxygen. Okay, here I have 2, here I have 1. Okay, how do I make them the same? Okay, if I times 2 here, sodium will be affected. Okay, so another thing I can do is to make this 1 is to put a half in front. Okay, this way is balanced. But remember, we cannot have fractions in our final answer. So we will have to multiply by 2 throughout. So 2 times 2 is 4. And here is 1. Half times 2 is 1. And here is 2. So check again, always check after you balance the equation. On the left 4 sodium, on the right 4 sodium. Here 2 oxygen, 2 oxygen. So this is balanced. You don't have to use this method. There are also other methods you can use to balance this equation. But this is just an example. I'm showing you where you can use fractions as part of the process in balancing. Okay, let's move on to another example. Another type of equations where fractions are useful is in combustion reactions that we've seen earlier. Okay, so again, remember this kind of reaction is combustion. And we always go in the order carbon, followed by hydrogen, followed by oxygen. Okay, so let's look at carbon first. On the left we have 4, on the right I will have 4 here. Then we go to hydrogen. On the left I have 10. So 5 times 2 is 10. Okay, the last one is to count oxygen. Here I have 8 and here I have 5. Okay, total here is 13. So what number should we put here to get 13? What times 2 give you 13? Okay, the answer should be 6.5, or you can write it as 13 over 2. Okay, so again, we cannot have fractions in the final answer. So what we can do is to multiply by 2 throughout. So here 1 times 2 becomes 2, right? Okay, here becomes 13. Here becomes 8, and here becomes 10. So you can see that fractions are especially useful when you are dealing with big numbers or coefficients when you balance equations. Okay, moving on to another tip. Okay, more often than not, you will see equations like that where they involve polyatomic ions. So instead of counting, if you were to count oxygen, good luck to you, we have lots of it to count. So one way we can do is to group the atoms together. Okay, so instead of counting oxygen here and oxygen here, we look at this as a sulfate and look at this as a hydroxide. Okay, so we begin by balancing sulfate. Okay, so instead of looking at individual atoms, we look at groups of atoms. So on the left, I have 3 sulfates. On the right, I have 1. So I can put a 3 here. Then we balance calcium. Okay, 3 here. So there must be 3 here, right? Then we look at the hydroxide. So 3 times 2, don't forget this, 6 here, hydroxide. So this one must be 2. So you see, by applying this, the process becomes very, very fast, and you can balance this kind of equations very, very quickly. This is also the first time we look at equation that have substances with brackets. So again, this is just to recap on your chemical formula. What is the difference between this and that? So remember, the number outside would apply to both of the elements that are inside the brackets. Okay, so this one, we have 1A, 1B, and X number of C. And on the right one, we have 1A, we have X number of B and X number of C. Okay, so that's the difference. Okay, pause the video, try the 2 examples on using polyatomic ions and grouping them to balance the equations, and I'll give you the answers after this. Okay, so over here, let's review. You should get a 2 here for the final answer. And for this one, you should get the 2 here, 3 here, 1, and a 6. Okay, do you get that? Let's move on to yet another kind of equation that you encounter very often, the one with alkali and ammonium salt. Okay, so we have alkali here, ammonium salt. You could do by the normal way of balancing, but this makes it very quick. So you look here, 1 ammonium makes 1 ammonia, and 1 hydroxide makes 1 water. Okay, just remember this rule. So let's just count ammonium and count hydroxide. I have 2 ammonium, 2 ammonia. Okay, if I have, of course I must balance the sodium. Okay, so after balancing sodium, 2 hydroxide will give 2 water. Okay, so this should be the final answer. Of course, this is a little bit more advanced as a tip, so if you are familiar with balancing equations, just bear this in mind. This will make it very fast for you. Okay, let's try the next one, again using the same idea. Of course, you must ensure all other atoms are already balanced. So we have to balance chlorine first, so 2. So that leaves us with 2 ammonium, 2 ammonia, 2 hydroxide, 2 water. So this is the final answer. Okay, so balance all other atoms except for the nitrogen and the oxygen. Okay, then you can use that tip to do the rest. Okay, down to the last tip for you. Okay, this is very useful. Okay, same increments. This is a seemingly simple equation to balance, okay, but if you do not know where to start, it can be a bit tricky. Okay, so if you look here, obviously if we have gone by our normal mode of thinking, we will look at hydrogen first, right? So hydrogen is balanced. Okay, 2 here, 2 here. Okay, then oxygen, I have 2 here, I have 3 here. Okay, then you are stuck because you don't know what to do, right? Okay, make some observations. You'll notice that the number here and the number here must be the same. Why is that so? Because this is H2, this is also H2. If I change this number, this will be affected. Okay, so no matter what I do, these 2 numbers will always be the same. Okay, and if by default 1 and 1 doesn't work out, you will try to increase by 1 step, which is 2 and 2, and if it doesn't work, you just increase by 1 more and 1 more. Okay, so trying 2 and 2, we find that the equation is balanced already. Okay, so this is what I mean by same increments. So look out for substances that have the same coefficient. Okay, then you can do some trial and error to balance it. Okay, for the more challenging equations, many of them require trial and error. We can use this tip for the last example, okay, which is this reaction here. Now look at this. Which two numbers do you think will have to be the same? Right, you'll notice that this number here and this number must be the same. Okay, so we leave that for a while. We balance the easy one first, which is iron. Okay, there are 2 here, so this number must be 2, right? And if 1 and 1 doesn't work out, let's try 2 and 2. Okay, is it correct? 2 carbon here, 2 carbon here, but it's the oxygen balance. There's 3 here, there is 2, so that makes it 5. Okay, and here is 4. Oops, it doesn't balance. Okay, so 2 and 2 doesn't work. Let's try 3 and 3. Okay, here I have 3. Okay, here I have 3 oxygen, so total here is 6. And 3 times 2 is 6. Yes, oxygen is balanced. Okay, so the final answer should be 3, 3, and 2. Okay, so this is the last tip for you. Hopefully with practice, you will get better and better at this. And that brings us to the end of the video. Hopefully you will have a better idea of how you can balance equations effectively from now on. Thanks for watching.